Okay. $15. All right, guys. Please go to the Google Doc that we have for the whiteboard. Let's see if I can paste in this in the chat. Okay. Chat. All right, today we're gonna go over the ransack algorithm, which you have to implement for finding the lines in the picture. Let's see. The ransack. It should be quite intuitive and yeah, these slides and easy to implement problem. So algorithm, so you can have time to do your project. All right. So let's see. There's kind of 4 steps I can summarize for you. So ransack. Today is April. Let's see. 17, 20. Ransack. All right. So the algorithm basically say the first step is to do 500 times according to the handout. The until happy thing. Repeat many times thing is repeat 500 times. Find best. All right, so what we do is we first to randomly sample 2 points, purely uniformly random to pick 2 points. And fit a line to it. The line would be y equal ax plus b kind of line. So this is by doing compute the slope is y2 minus y1 divide x2 minus x1, and the intercept is y1 minus slope. This clear. So since we have this slope is slope times x1. All right. Then the second step is to find all the points that is close enough to this line. So you're gonna get a set of points that the distance between the points and the line is less than, say, 2. All right, find this set of points. All right, I think we need a new page. Then in the third step, we have to refit the line. With all inliers. This step would do by the Wikipedia formula, which is suggested in the handout. This is called I think it's a Deming regression. So if you Google the Deming regression, if I just do a Google, yeah, this is the one I found, regression. And then here is the, so in the solution session is what we want. All right. And then first we compute the mean from all the inliers by sum of them and then divide by the number of the inliers, and then find the mean for the y. And then we compute this sxx, and then we compute this sxy, and we compute this syy, and then plug them in to find the slope and the intersection for the line. All right, this is step 3. So step 4 basically is just go to step 2 until the line does not change. Right? You find the same line compared to the previous iteration. Go to 2 until the line. All right, that's step 8. You do this 500 times to find the best line. That is one line. All right, and then you have this one line, you have to split them. So then we go to this step B, which we didn't talk much about during the class. So the B step is, once you have the line, you split it. By the distance between points projections. All right, you projected the points onto the line and then split the line by the distance. So you have a line, you have some layers, then you have all the projections. So you have all the points. On the line. And then you look at this distance to decide if this is a segment or not. All right, so you look at this distance, this distance should be small enough to be decide how many segments you have. So say here maybe we have, this is 1 segment, this is 2 segment, 3 segment, 4, 5, 6, 7, or maybe this 2 is together. I know. So each the green thing is a segment here on your line. And then you throw away your question?
We're doing this after we've completely decided on all of our models, like we've laid all our lines out.
Yes, this is step B. So in step A, you just want to find one line, a very infinite long line, because you have the formula. The line defined here is the formula, right? So it's an infinitely long line here.
Right. Are we doing this after we've picked out all of the lines, or just one though?
Oh, just one.
Okay.
Yeah, just one. So we find each segment of line at a time, one at a time. All right. So we do this, and then we find the formula, and then given the formula, we do all the projections, and then we try to find the projections. And then we split them into segments, and then we only keep, okay, so we need, so we only keep the segments with enough density. With this I here. All right, so maybe another color. So say we only keep them with enough density. I don't know, this goes away, maybe this goes away, this goes away. So we have 3 left. And then in the rest of the segment, we keep the best segment, keep only one segment. The best could in terms of the densities, all right. So basically, I think we only select the ones. Yeah, I think we can keep multiple segments here in this step. So what I mean by written down, keep the best segments.
Step C on the assignment makes it sound like we only keep one.
Okay, yeah. So maybe you do want to keep just one. Yeah. So do I have the handout? This is not. Yeah, I think you want to keep only one segment. Have a sufficient number of inliers and a sufficient density of inliers, say 0.7, call the one that explain most inliers the best. Yeah, most inliers. Okay. So most inliers here. So this one has 3 inliers, this one has 3. This one has 3 inliers, this one has 3 inliers, this one has 2. So maybe these 2 are both best inliers, and then I will break tie on the density. So this one looks better. So yeah, maybe go with this one. So all right, and then this is the only line we find. So one line find, one, I would call it segment, one segment find, and then repeat step A and then step B to find the segment, second segment. with all the data that throw away these 3 data points. So actually this 3 data points. So this data point is not there. This data point is not there. So maybe, oh, maybe there's another data point here. Oh. So exclude these 3 data points, and then do this step A and step B again. All right, that's pretty much what you have done in your code. What you have to do in your code. Any questions regarding the line finder algorithm rensec? Okay, there's something in the chat. Okay. All right, so okay, so then for the graduate students, we have to find a circle, and then it's pretty much the same, but we don't have to do refit. So there's a no refit, no naming regression. Yeah, no step 3 here. We don't have to refit. Otherwise, we have to do is find a line, find a circle, and then keep the one that that has enough inliers and then enough density. Do we even need the density? Don't worry about refitting. Find the distance of a point in a circle is easy. Find its distance from center to the radius. Yeah. Yeah, I think enough inliers would be good enough.
Is there a rough rule for how many inliers a circle should have?
I don't know. So maybe you want to do some experiment on that, or 7 using the same as the number in lines. Yeah, just try 7. If it doesn't give you better results, increasing that.
Okay.
Okay. All right, this should be really straightforward. All right, any confusion among this algorithm, please speak out loud. And then, yeah, if I were you, I will spend more time on the project, because the project would give you a larger portion for your final grades. All right, if there's no questions, feel free to go ahead and then implement it. If you already implemented it, go ahead and then do your project. And that's it for today. Well, that's for me. All right, have a good weekend, guys. So stop sharing. Okay.